Now we saw the fundamentals of linear regression, we saw the model, we saw the equations. Now we will see how to evaluate the linear regression model. The idea is basic. We will use different loss functions, different error metrics. If you ask this kind of questions, how to calculate the accuracy for the model, actually it is not a good question. Because here we are not doing some classification. We are trying to do some regression. Therefore, we should focus on the error, not the accuracy. But of course, if you are doing some classification, you can focus on, or you can highlight the accuracy. Therefore, the right question is how to calculate the error for the model. And you already know that we will use loss function. We will use different error metrics, and these are the major ones. Of course, there are more, as you'll see in the previous slides, but I will just explain these ones. Mean squared error, root mean squared error, mean absolute error, and R squared. Okay, here, this is the mean squared error, MSE, and the formula is quite simple. As you see, this is the difference between the actual value and the predicted value. In other words, this is the error, there is a squared operation, and this is the formula of mean, sum of all values and divide to the n, right? This is the mean. So mean squared error. You don't have to memorize it, but just try to understand the logic behind this formula. We will find the error, for each error, we will calculate the square root of that error, and we will find the sum of all squared errors, and we will divide to the n to find the mean, right? Okay, and the root mean squared error, RMSE, is just same with the MSE, but you should add this root operation after the result. And the mean absolute error is slightly different. As you see, there is no squared operation. So this is the mean part. So this is the error, and these are the absolute. So mean absolute error. We will see the differences in the next slides. And this is different from the previous one. The previous one, as you see, we are calculating the error. So for this matrix, we will try to minimize their results, their values. But R squared, in other words, coefficient of determination, is something different. Let's look at the formula. As you see, R squared equals 1 minus RSS divided by TSS. RSS is residual sum of squares. TSS is total sum of squares. And when I say residual, this is same with the error. So the RSS formula is like here. Find the error, and there is a squared operation here, like in the MSE. But the difference is we will not divide these results to the n. We will just find the total sum for this residual. Here we have TSS formula. It's quite similar, but we will find the difference between the actual value and the mean of the values, okay, not the predicted value. Here we have again squared operation, and we will find the total sum, and we will not divide to n. So what if they are equals? Then the result of this part, right, as RSS divided by TSS will be 1. So 1 minus 1 will be 0, right? If the difference between the actual value and the mean is too much, variance also will be bigger. And if the error is too small, then the result of this part will be close to the 0, right? Then the result of all of these, 1 minus 0, will be 1. Or if it is too small, the result will be close to the 1. So if our model is good enough, this metric should be close to the 1, not to the 0, like the previous ones. We will see some examples to understand better. Okay, here think that we have predicted value and actual value in these columns. So what is the error? Error is the difference between the predicted and actual. So here 421,502. This is the sum of error, okay, 14. And this is the squared for each one. So for this first one, 4, 16, 2 will be 4, 1 will be 1, 5 will be 25, 0 will be 0. As you see, if there is no error, then there is no difference between the squared operation. Or if the error is too small, like 1, then difference will be also 0 or very small. As you see, for the 5 difference is 20, but for the 2 difference is the 2. So you can see the effect of the squared operation. If the error is too much, then the model will be penalized also too much. Okay, let's look at the MSE, RMSE, and MAE, mean absolute error. So here we found the total of this squared as 50, and we have 6 examples, so n is 6, and the result is 8.33. And for the RMSE, we will just implement this operation to the result, and it is like something 2.88. And for the mean absolute error, so we have this sum, we will not use this squared one, we will this used, and 14 divided by n6 is 2.33. So as you see, even if you have same values, same actual and predicted values, the metrics will be different. And the major difference is, if you are using MSE, if you are using squared, then the model will be penalized too much when the error is larger. But in the RMSE, because of the root operation, for example, if these are dollars, then again the result will be dollar. If it is $84 RMSE, this 2.88 means root mean squared error is $2.88. Okay. Now let's look at the this difference between the actual value and the mean. Here the mean is 106.33. So according to that operation, we will find this total sum of this mean and the square of this mean. And then when we implement these values to the formula, when we use that, we will find something like this, 0.96. So it's too close to 1. So that means, as you see, RSS is very small comparing to the TSS. Then the result is close to 1. So it's good because the error is low and the variance is not low. Okay, for these values, we obtained these results. As you see, we will try to minimize these ones, but our squared will be something between 0 and 1, and we will try to find the values close to 1. And this method is not enough without these ones. Therefore, be careful, sometimes it can be misleading. But if you have one of them from this and this one, it will be better to understand the model's success. Okay, some important notes. Remember, squaring operations inflated or magnify large errors. More punishing effect on model when it is used as a loss function, because exponential increase in the value. And RMSE is mostly used because same units with targets. If target is dollars, then RMSE will be dollars, and it's more understandable, especially in reporting and testing. But you can also use MSE in training and then use RMSE in testing and reporting. This is also a common approach. And mean absolute error, unlike the others, change is linear and all errors are equal. Because there is no squared operation, all errors are equals. Of course, the mean value is 0 for the all MSE, RMSE, MAE, and be careful about R squared. Don't try it on without other metrics. Okay, now we completed the theoretical part, and I will show very simple linear regression notebook, Jupyter notebook. Some terms, some equations, some results that we discussed in the previous slides on Jupyter notebook.